Welcome to mathematics. Today we're gonna do an integral of square root of 4 minus x squared from 0 to 1. You can use the chi sub here. It's named trigonometry substitution here, but I'm going to do it as a geometric way. The graph of square root of 4 minus x squared is pretty much just the semicircle be a square root of something, and it's always gonna be positive, so we only want the positive side. So this from negative 2 to 2. This is the graph of y is equal to square root of 4 minus x squared. Here, the area we're gonna find is from 0 to 1 like that. 1 here. Here is the deal. We're gonna find the area of this thing. So here is the deal. First, we're gonna draw a line here, and then this right triangle, and then what's its height? And its height is just put a 1 here. You get 4 minus 1 square. You get square root of 3 here. So the first area is just the area of a triangle is this square root of 3 times 1 and then over 2 like that. And then the second one is just this. So this is the center. This is the center. So let me just put it here. 1/2 times the radius. So radius over is just 2. The radius of the circle. So this 2 squared and then multiply by our theta. So what's our theta here? Theta here, let me draw a line here. Draw another line here. And we know that radius is equal to 2 here, and then this length is just 1. So use our inverse. Theta is just equal to inverse side of 1/2. So this is equal to pi over 6 like that. So over you just get square root of 3 over 2, and then 2 squared is 4, and then 2 and 4 they cancel, they simplify to 2, and then over you get 2 pi over 6, you get pi over 3 like that. And that's our answers. Square root of 3 over 2 plus pi over 3 like that. The integral of e power of inverse x from -1 to 1. First, we're gonna use our u sub let u is equal to inverse sine x, and then take our original side, you get sine u is equal to x. So differentiate both sides, you get cosine u du is equal to dx. So over you get put -1 into here, you get negative pi over 2. Put 1 into the inverse x sine x, you get positive pi over 2 like that. And then here is the deal, and then this is just e power of u times cosine u du. And here is the famous one. You pretty much you just get 1/2 times e power of sine u plus 1 over 2 times e power of cosine u. And then we're gonna plus 0 and no, negative pi over 2 and then pi over 2 like that. Since it's not an R function or even function, you can put negative, let f of x is equal to e power of inverse size, and then put negative x. You will not get that negative fx of f of x, negative f of x or f of x. And then first put pi over 2 into it. Sine, first you get 1/2 times e power of pi over 2. Since sine pi over 2 is 1, so over you just get 1/2 times e power of pi over 2, and then put pi over 2 into the cosine. Cosine pi over 2 is 0, so never mind. So plus 0, and then we're gonna subtract, and then put pi over 2 into it, you get negative pi over 2, it should be. And then e power of negative pi over 2, and then sine negative pi over 2, you get -1. So multiply by -1, and then put negative pi over 2, it's still 0 like that. So overall, you just get same denominator, and then this e power of pi over 2. And then negative become positive, so plus e power of negative pi over 2. So over you can leave this as the answers, but this the same as the form as e power of x plus e power of negative x over 2. So this is the hyperbolic cotangent. Hyperbolic cosine is named as cos of pi over 2. Like that is the answers. The integral of x squared times e power of negative x squared from 0 to infinity. First, we're gonna use the integration by part. We're gonna differentiate x and then integrate x times e power of negative x squared. Differentiate x, you get 1, and then integrate this. Do this in our head, like u is equal to negative x squared. Du is just equal to negative 2x. So over you just get e power of negative x squared, and then multiply by -1/2 like that. So if you differentiate that, you will get that, and then don't forget about the chain rule. You're gonna multiply by the derivative of negative x squared. So multiply by negative 2x. So multiply by -1/2 to cancel the derivative of the chain rule. the constant that get from the chain rule. So overall, this time that is the first part of the answers, and then this negative x over 2. I'm going to bring e power of negative x squared into the denominator, so this over e times e power of x squared, and then we're going to put 0 infinity later, and then negative 1 times negative 1/2 is positive 1/2 times the integral from 0 to infinity, and then e power of negative x squared dx like that. So overall, if we put infinity inside, and then e power of infinity squared over the denominator, you get infinity, and the infinity over infinity is an indeterminate form, so we have to do more work. So we're gonna use our limit at x approaches to infinity, and then negative x over 2 times e power of negative e power of x squared, and then we're gonna use our last bit rule since it's an indeterminate form, right? So overall, you get limit at x approaches to infinity, and then derivative of x is just 1. Derivative of this, first you get e power of negative x squared, and then don't have a negative, and then multiply by the derivative of x squared, you get 2x. So overall, put infinity inside, so 1 over infinity, so the over you just get 0 like that. So over you get 0, and then put 0 into it, you still get 0 here. And then over, this is the integral of e power of negative x squared from 0 to infinity, and this is the half of the Gaussian integral because it's an even function and it's go from 0 to infinity. We're gonna take a half of this. So take a half of this, so this the same as multiply by 1/2, so it's 1/4 from negative infinity to positive infinity of the integral of e power of negative x squared. So this is the Gaussian integral, and this equal to square root of pi. So over, you just get square root of pi over 4 like that.